From steel bar to ocean giant, the making of a 500-meter anchor chain. Part 1. How does an ordinary steel rod become a colossal 500-meter chain capable of holding the world's largest ships? The answer lies in an extraordinary blend of extreme heat, immense pressure, and precision engineering. These chains are the lifeline for billion-dollar cargoes and the safeguard for thousands of crew members at sea. A single defective link could lead to disaster. Let's explore the incredible journey of how these monstrous chains are forged. Step 1. Cutting the raw material. It all begins with high-quality, resistant steel alloy bars, the foundation of one of the shipbuilding industry's toughest components. A bridge crane moves the heavy bars to the production line starting point. First, an automatic band saw cuts them into exact segments. The blade performs a cold cut through the dense steel, producing ingots that will become individual chain links. Each of these units weighs over 100 kilograms and measures 5 inches thick. Once cut, the ingots are grouped and stored, awaiting the next phase. Step 2. Heating and bending. Hundreds of ingots wait to enter an induction furnace, where heat makes them malleable. One by one, they pass through the furnace. A magnetic field raises their core temperature to 1,600 degrees Fahrenheit in seconds, leaving them glowing red hot. The ingot then moves to a press where jaws hold it firmly. A mold preforms it, and an arm bends it into a precise J shape. Now comes the critical moment of joining. An operator uses long tongs to insert the U-shaped link through the previous finished link. Then, with careful precision, he places it into the next press station. A horizontal press, generating hundreds of tons of force, pushes the two ends of the U together to form a closed loop. Step 3. Welding the link. The link is closed, but the joint isn't permanent yet. To fuse the two sides into a single indivisible piece of steel, the red-hot ring is moved to a welding machine. 2 copper electrodes grip both sides of the joint firmly. An intense electric current is applied. The steel's resistance to the electricity generates extreme heat, melting the metal at the contact points. This process, called resistance butt welding, creates a molecular bond, making the joint as strong as any other part of the link. Step 4. Removing the burr. The weld is successful, but it leaves behind excess solidified material known as burr. To remove it, the link goes into a final press. Hardened steel jaws hold it precisely, while other surfaces push against the welded joint with enormous force. Within seconds, the burr is sheared off cleanly, leaving a smooth, uniform surface ready for extreme loads. The process then repeats for the next link. Step 5. Making the stud. Simultaneously, another crucial process unfolds. Manufacturing the stud, the internal bar fixed in the center of each link. The stud prevents bending and deformation, multiplying the link's strength. Steel segments are collected, heated in a furnace, and then placed into a stud forging machine. Step 6. Inserting the stud. Back on the main line, the welded link, still hot, is positioned in a vertical press. A special mold gives them their characteristic shape. Hundreds of studs are produced per hour. As the link cools, it contracts, trapping the stud with thousands of tons of force. As an extra safety measure, a welder applies a bead to the joint, ensuring zero movement under extreme conditions. An operator inserts a cold hammer into the center of the hot link. The temperature difference is key. 2 powerful side presses activate, pressing the link's sides against the stud's ends. Step 7. Crafting the bow shackle. The chain still lacks its most critical part, the bow shackle, which connects the chain to the anchor. This component must withstand even more pressure than a standard link. The process starts with a block of carbon steel chosen for its high strength. An industrial saw cuts it into sections, each cut taking 15 minutes, producing a 265-pound ingot. After hours in a furnace, the ingot reaches over 2,200 degrees Fahrenheit and is placed under a 6,000-ton forging press. The first blows compact the metal, improving its internal structure. A manipulator arm holds the piece while the forge continues striking to create wider ends that will become the shackle ears. The preform now has a narrower body and 2 widened ends. Step 8. Final forging and bending. The preform is reheated, then transferred to a bending machine. A central piston holds it while 2 hydraulic arms slowly bend it into a characteristic U-shape. Quickly, before it cools, it moves to the final press. Any oxide scale is cleaned off with pressurized liquid. The press descends with immense force, filling every cavity of the mold and defining the shackle's final shape. Excess metal is squeezed out as burrs and then cut away by a die press. Please watch part 2 for next episode.